Hi guys, this is Leo Chen. Today we're going to learn about factoring and roots of a higher degree of polynomial. First, let's start with the introduction for factoring higher degree of polynomial. That's our example. We're going to factor this polynomial today. So, in this type of problem, we need to factor this polynomial into its simplest form. We'll also find all the zeros. First, let us look at the example. X to the 6th power minus 2x to the 4th power minus 4x squared plus 8. It looks like intimidating, but do not get scared with this. It's not as hard as it looks. It's actually pretty simple. Alright. So, in order to factor a higher degree of polynomial, we need to be familiar how to factor simple polynomial. In this case, we'll factor this higher degree polynomial by grouping. Be aware to simplify as much as possible, including all the differences of squares. So you know how all people like look at the problem and just like think, "Oh, what is that?" Alright, let's start it. Grouping. We start with grouping. By grouping, we'll draw our imaginary line in between the equation. Then, we will treat as two different groups of polynomial. First, we need to know, where do we draw the imaginary line? Where the heck is the imaginary line? It should be drawn. So, just a note, we will always draw our imaginary line in between the higher degree and lower degree term. So let's look at the example. It's x to the 6th power minus 2x to the 4th power minus 4x squared plus 8. So it looks like x to the 6th and minus 2x to the 4th belongs to higher degrees, and negative 4x squared plus 8 is like second degree and first degree. So in this case, it will be drawn between 2x to the 4th power and negative 4x squared. Also, we have to always draw our imaginary line in between two groups where the greatest common factor we can get. So now we'll draw our imaginary line. We'll draw in between 2x to the 4th power and negative 4x squared. Here's our imaginary line, yeah! Now we will start factoring. That's our imaginary line with polynomial from previous one. In the first group, we can see our greatest common factor is x to the 4th power. Let's see. So we both have x on both sides, so we can divide by x to the 4th power on both sides as well. So let's go ahead and do it. So divide by x to the 4th, x to the 6th divide by x to the 4th power, we got x squared left. Negative 2x to the 4th power divided by x to the 4th power, we got negative 2 left. So let's put in parentheses. In our second group, our greatest common factor is negative 4. Notice, see, 8 can divide by 4, right? So we divide by negative 4. Negative 4x squared divided by negative 4, we only got x squared left. And 8 divided by negative 4 is negative 2. Now let us look at our two groups of polynomial. Note, it is same like x squared minus 2 on both sides. So we see the same factor on both sides. Now we'll go ahead and treat our two groups as one polynomial again. So we're going to factor the x squared minus 2 out now. Let's divide by x squared minus 2 on both sides. Right here, right here. Now x squared minus 2. We got x 4th left and minus 4 left. So now we'll group this together. Group x to the 4th power and negative 4 together. So it's our final factor form become x to the 2nd power minus 2 in parentheses times x to the 4th power minus 4 in parentheses. Alright. Now, remember, we have to always check in for the difference of square. Let's go ahead and start it. So according to the previous slide, we got our factored polynomial, which is x squared minus 2 in parentheses times x 4th minus 4 in parentheses. However, we have to check for the difference of square. According to the difference of square root, x squared minus y squared equals x plus y, x minus y. So I need to square. So let's look at this, or the first group. We got a square, we got another x squared, this is square, and we got like -2, which is not a perfect square, excuse me. But we can still factor that out. So our second group, yep, this one is a perfect square, and the 4 is a perfect square. So now let's factor out the difference of square. Arrow. So this will become x squared plus 2 and x squared minus 2 to factor out the difference of square. And this will become x plus square root of 2 parentheses x minus square root of 2. After we factor out the difference of square, we will have to check for difference of square one more time. So here we check, we're good. Here we don't have any left, but here we have another x squared and minus 2, which is same as this one, exactly the same. So now we have to factor out the difference of square one more time, become x plus square root of 2 in parentheses times x minus square root of 2 in parentheses. After we factor out all of the difference of square, we will have to simplify our final solution. So currently we got x plus square root of 2 times x minus square root of 2 times x plus square root of 2 times x minus square root of 2 and times x squared plus 2 again. Oh, that's a long equation. That's a long equation right here. Now we'll combine the like terms. Notice how we have 2x plus square root of 2 in parentheses. So we'll go ahead and write them as like x plus square root of 2 in parentheses square. Notice we also have x minus square root of 2, like 2 of these. So we'll also group them together, x minus square root of 2 in parentheses square. Now it looks way more concise. We can go ahead to approach our final steps. Solving for 0. Okay, according to previous slide, we got our simplified form. X squared plus 2 parentheses times x plus square root of 2 parentheses square and times x minus square root of 2 in parentheses. Okay, now we will solving for 0. To solve for zeros, we are looking for the number goes into x in order to make the equation 0. So we'll go ahead and deal with this in like 3 different groups and treat each one as a complete equation. Goes with the 0 property. Alright. Sorry. So x squared plus 2. Alright, we'll go ahead. Okay. Sorry, I'll get to solve for 0. Alright. So go ahead, x squared plus 2 equal to 0. Alright guys, sorry, a little bit mistakes. Again, let's go back to here. So now let's start with this one, x squared plus 2 equal to 0. We subtract 2 on both sides, x squared equal -2. And square root on both sides become x equal to square root of -2. We got square root of -2 as our first 0. However, it is not a real number. Therefore, it cannot be a x-intercept. We'll ignore it right now, so we disregard this answer. Let's go with this second group. X plus square root of 2 in parentheses square equals 0. Now a square root on both sides, square root of 0 is still 0. Now x squared plus square root of 2 equals 0, or subtract square root of 2 on both sides. So now we will have x equals square root of negative square root of 2. Notice how I use parentheses around the negative and the square root sign. It is not the same as like negative square root. That is not equal to the negative square root with the parentheses. Alright. Now let's go with the third group. X minus square root of 2. X minus square root of 2 in parentheses square equals 0. Square root on both sides, we got x minus square root of 2 equals 0, plus square root of 2, so x equals square root of 2. So now after solving zeros for the next two groups, we got square root of 2 and negative square root of 2 as our two zeros. Now we will start to graphing for zeros. After we figure out all of our real zeros, now we can go ahead and put it on the graph. Be aware square root of 2 and negative square root of 2 are our zero. So square root of negative 2 is not a real number, so we cannot graph this on our coordinate plane. Square root of 2 is around 1.414, so which is this green dot over here. And negative square root of 2 is about negative 1.414. This orange dot. So remember how our zero represents an x-intercept? And we graph the entire polynomial, which is the original one. X to the 6 minus 2x to the 4th power minus 4x squared plus 8. Our zeros will be the x-intercept, which is negative 1.414 as an approximation, alright? And positive 1.414. And the entire equation looks like hooey. Congratulations! Now we successfully factor the high degree polynomial and find its zeros. Thanks for watching, guys.